Good afternoon and welcome to this webinar hosted by Element 14 in collaboration with Agilent Technologies. Today we're going to be talking about creating complex, flexible signals with modern waveform generators. Very fortunate to have with us from Agilent David Tu, application scientist, and Marlo Manalotto, also of Agilent. If you have any questions for the panel during the course of the webinar, please put them into the Q&A window and I'll ask them at the end. Without further ado, I'll hand you over to David Tu. Take it away.
All right. Thanks a lot, Christian. So thank you for attending this webinar or maybe listening to this on the recording. But we are talking about creating complex, flexible signals with modern waveform generators. But that's kind of a complicated title, so let's go ahead and talk about what the subject is. So primarily, we'll actually be covering the use of arbitrary waveforms with the new 33600A series waveform generators from Agilent Technologies. You're probably familiar with a function generator, but modern waveform generators actually have a number of performance upgrades and features that will really benefit you, especially when you're using an arbitrary waveform. I'll touch upon other areas too of the generators, but the general theme and focus of this webinar is on arbitrary waveforms. So let's go ahead and get started. Oh, actually, I did want to mention that Agilent Technologies, the electronic measurement side of Agilent Technologies, is changing over to Keysight Technologies. So if you do want to email me, my email will probably be changing over in the August or November timeframe to david_2@keysight.com or something like that. Before we get too much into the presentation portion of it, I did want to go over the webinar logistics. So for about 45 minutes, I do have a presentation and some live demos for you to view. The phones are going to be muted on your side, so it's really just going to be a one-directional conversation. This way, other people on the phone won't be distracting you with their coughing or maybe their kids crying, or actually I've been on the phone sometimes and I've actually heard somebody vomit, which is, so we won't get any of that. However, if you do want to ask questions like Christian said, you can ask them in the webinar, the WebEx chat window, and towards the end we'll have 15 minutes allocated for just answering your questions, and I'll do the best that I can. After the webinar is over, we will be sending a link to you to view this recording of the webinar once again, just in case you missed the sound of my silky smooth voice, or you really need some help falling asleep one night. You can do either one, and you can watch this over and over again just because it's going to be such an exciting webinar. A little bit about me. My name is David Tu. I have been with Agilent Technologies for about 14 years, but the first 13 years of my job was working in production and R&D as a test engineer. So I have actually a lot of experience developing test systems and working with test and measurement equipment. But over the last year or so, I've been moved over to a more of a customer-facing role. And in that role, I actually do a lot of application briefs, white papers, some YouTube videos, actually, and a lot of training activities such as this webinar. But in addition to all that activity, I also have some informal documentation and informal writings that I put up on our blog, which you can see on this URL right here, japidi-neal.blogspot.com. So actually, if there are any questions that I can't answer directly from this Q&A session at the end, I'll probably take the time and write my answers onto the blog. So if you have some questions I can't answer, please check the blog within the next week or so. So let's talk about our agenda. So we are focusing mainly on arbitrary waveforms and the 33600 series. So I will give you guys some information about the 33600 series as well as Trueform technology, which is a breakthrough technology for Agilent. We'll actually do a jitter performance comparison. We'll see some screenshots from a real high-end scope with that. And then we'll actually do some live demonstrations. I have 3 live demonstrations that I've got planned for you. The first one is comparing arbitrary waveforms with a Trueform generator versus a DDS-based generator. And if you don't know what DDS means, I'll be covering what DDS is later. The second demonstration will actually be capturing and recreating a waveform that I capture with the Agilent oscilloscope and then recreate that with the 33622, 33600A series Trueform generator. So that's going to be pretty exciting, and it's going to allow you guys to be a lot more productive if you do a lot of that type of capture. Finally, we will be covering sequencing for Arbs. So sequencing arbitrary waveforms is something brand new, but it's actually going to allow you guys as a designer and user of arbitrary waveform to be a lot more efficient. It's going to save you some time, not only in the design mode, but also in the use of your arbitrary waveforms. So let's go ahead and get started. Some base information, you guys probably know this, but a waveform is the shape of an electrical signal. And we have waveform generators and function generators. So traditionally, a function generator can output basic mathematical functions such as a sine wave or a square wave or maybe a ramp wave. A function generator is really useful to be able to change the amplitude or the frequency of your signal. And the reason it's called a function generator is because of those math functions that it's able to output. So in addition to those math functions, you can actually output a pulse wave, which is like a square wave, except that you can change the rise time or fall times, your pulse widths or duty cycle, or in addition to that amplitude and frequency. One of the main differences between an arbitrary waveform generator and a function generator is the ability to output arbitrary waveforms. An arbitrary waveform is a custom signal that a user defines, and that could be a real-world signal that you capture from a scope and try to output, or it could be a complex signal that you design in a software program such as MATLAB or Excel or some other piece of software. So that's really the main difference between an arbitrary waveform generator and a function generator. And the accuracy that you have with an arbitrary waveform generator is going to make a large difference. And then we have a noise signal, which you guys are probably familiar with as well. So let's give you a little bit of a history lesson. Back 75 years ago this year, in 1939, Hewlett and Packard designed their very first product, which was the HP 200A audio oscillator. And that product actually kick-started Silicon Valley, which has made a ton of millionaires, I guess, now. But the audio oscillator was a very innovative product, and one of the innovations of that was that it actually used a light bulb to, as a voltage regulator to really greatly improve the output distortion of this signal generator. So 75 years later, Agilent is still carrying forth that legacy of being innovative and manufacturing and designing waveform generators. In fact, Agilent is still the #1 provider of waveform generators, and we're not stopping. We're still innovating here, and we're going to see that with Trueform technology. So I wanted to give you guys a little bit of a trivia question. So one of our first customers for HP's 200A was a very large movie company, very famous. I'm sure you've heard of them. And I want to give you guys a couple seconds to try to guess what that company was and which movie it might have been for. So that movie was actually Disney's Fantasia. And another piece of trivia is that the sound engineers that actually worked on Fantasia and bought those 200As won Oscars for their work on Fantasia. So what does that mean? That means that by association, HP won an Oscar for their work and Agilent won an Oscar for work. And kind of I'm stretching a little bit, but it means that I won an Oscar for their work as well. So I'd like to thank the Academy for their hard work and whatever, sorry, bad humor. Let's continue with the history lesson and move forward towards Trueform. But early waveform generators actually were separate instruments between a function generator and a arbitrary waveform generator. These were analog instruments, and they were actually fairly expensive. And because of their analog nature, they had some limitations in terms of bandwidth and use. One of the problems with having such an expensive product is that you really couldn't have generators on each individual's desk, so that they were centralized, and it was just a lot harder to use. back in the 70s and 80s, the test and measurement industry actually moved over to this DDS-based technology. DDS stands for Direct Digital Synthesis, and this is a digital technology that is used to simulate your waveforms. And with the advent of DDS-based technology, everything became a lot cheaper. Now every engineer, every technician, maybe a lot of hobbyists can actually have generators on their bench now. So that made these generators a lot more available. The only issue with this DDS, there's a major flaw with this DDS-based technology, however, is that when you do output an arbitrary waveform, there are some issues in that the DDS-based technology will actually skip some points. And so that flaw is going to be inherent with all DDS-based generators. Unfortunately, well, I guess fortunately for everybody that has a generator, that made everything cheap, but the generators are all going to have this flaw. So the function generator that you probably have on your bench right now, it is going to have this DDS-based flaw. So since every vendor, every test and measurement vendor uses the DDS-based technology, it's not exclusive, and Agilent changed the paradigm a few years ago. So Agilent actually came out with Trueform technology, which is the next generation of waveform generator. This is exclusive sampling technology for Agilent Technologies, and we're the only one that can do this. So the major advantages for this technology is that if you're using an arbitrary waveform, you are able to get a true point-by-point arbitrary waveform. We're not going to be skipping points like a DDS-based generator does. Some performance aspects of the generator is that it is able to do 200x lower jitter than a DDS-based box, and we'll actually see that in our later slides. And we also have a lot cleaner signals than a DDS-based generator will have. So let's go ahead and introduce the 33600A series generator. This does have Trueform technology, and this product actually just came out a few months ago, so it's brand spanking new. But it does have that exclusive Trueform technology built in. Some of the Trueform benefits are this: we have lower distortion than a competitor's DDS-based box. So we have 14 bits of resolution and improved design in the filtering circuits and amplifiers to allow us to get this improvement on our total harmonic distortion. Harmonics and spurious signals are lower in a Trueform generator than any other waveform in its class. Next, we have that jitter that I mentioned earlier. So 200 times better. Actually, we can achieve less than 1 picosecond in our waveform. So that's really going to be important if you're a digital designer. Now you can use our Trueform box instead of a more expensive $20,000 or $30,000 digital box to simulate your waveform. So this is going to allow you to do a lot more testing just on your bench with our function generator that we have here. And finally, we do have that better signal fidelity. So I mentioned that we're not going to skip points like a DDS-based box will, so that's going to be really important, especially at those higher frequencies. And we are anti-alias, and you can play this at any rate. So a little bit more information about this 33600A. This is a series of generators, so we do have 4 models within this series. You can get an 80 or 120 megahertz version, and you can buy those in 1 or 2 channel models. So with those combinations, we have our 4 different models. The Trueform generators can do 2-channel synchronization. They have the ability to do PRBS signals, which is a pseudo-random binary sequence. So if you are testing digital data link, that type of pattern is going to be very useful for you. Some of the key specifications are that not only can we go up to 120 megahertz with a sine wave, but we can actually go up to 100 megahertz with a pulse waveform, which is at least double what our competitors in the same price range can do. We are having 1 gigasample of sampling rate and our 14-bit of amplitude resolution. So all of this performance upgrade and additional features for a very competitive price of $4,000 to $6,700. Okay, so a lot of background information. It kind of flew by quickly, but the bulk of this webinar is actually going to be the performance comparisons between arbitrary waveforms on a DDS and a Trueform generator. So what I have here is actually just a normal pulse wave. This is not a arbitrary waveform, but this is a pulse wave that I'm outputting with a Trueform generator and a DDS generator. So the Trueform generator is in yellow, and the DDS generator is in green. The pulse waveform is just a 33 megahertz pulse, 1 volt peak to peak, and 5 nanoseconds of rise time. The particular scope I'm using here is a series 90,000 scope from Agilent, which has a very high bandwidth, which allows me to see jitter a little bit better. Give me a second to drink some water. So let's actually try to view the jitter on this. So this is a single sweep, but if I put the scope into a different mode, we can actually see the jitter manifest itself differently. So I put the scope into a roll mode, which is ROLL. So I can actually see jitter differently now. And so with a roll mode on a scope, it's like a slow strip chart. So what it does is it requires a repetitive signal to build the waveform. So it does it fairly slowly on the screen. And because of that, it actually digitally subsamples the scopes, the signals, in order to build what you're seeing on the screen. Since each waveform takes a little bit of time to build and sample, we actually can see the jitter manifest itself as voltage noise and jitter noise. So in reality, this type of signal is what your device is going to see on your DUT. So this is just a really neat way of seeing jitter in a real world term. This particular signal actually has about 500 picoseconds of jitter on the signal, whereas you can see our Trueform solid line, that's going to be less than 1 picosecond of jitter. So that's pretty incredible. Just to kind of recap here, even with a normal waveform, I didn't even use an Arb for that demonstration. Trueform clearly has a better jitter than that DDS box that I was using. This allows you to test a lot more digital applications or applications where timing is really critical, because now you've got that great jitter stability at a very competitive price that other function generators cannot do. So one last note about jitter is that you can achieve less than 1 picosecond of jitter in all waveforms, not only arbitrary waveforms or pulse waveforms, but sine, squares, everything that the generator can output, the Trueform generator can output. Okay, so let's go ahead to our next demonstration. I want to show you guys how a Trueform Arb actually differs and performs better than a DDS Arb does. So on my bench, I have a few instruments here connected to my PC. I have an oscilloscope, and I have a Trueform generator, the A33622A, and then I also have a DDS-based generator. So again, in this demonstration, Trueform is going to be the yellow trace, and the DDS is going to be the green trace. I'm going to open up another program here that you might or might not be familiar with. This program is called BenchVue. It is a new program from Agilent Technologies, and we'll actually be using this to control and view our measurements from our 3 instruments. So what I wanted to do is kind of just set up everything from scratch for you, and just so you can see how easy it is. So first I'm going to do is load up arbitrary waveforms on my 2 generators. On my first tile here, I've got my 33622, which is that Trueform generator. In my second tile, I have my DDS-based generator, which is actually the 33250 from Agilent Technologies. Again, a very good box, but using that DDS-based technology. And then finally, on this third tile, I have my oscilloscope here, which is a 4154 model scope. So on my 33622, I'm going to browse and load up a waveform that I have already designed. And it's a very basic waveform. It looks mostly like a square wave, but it's got 7 glitches on top of here. So these small aberrations are going to show up on our signal. And let me do the same with the DDS space generator. So I'm going to select Arbs and then press Browse to look for that waveform, and it's going to be called glitch. Now that I've loaded the glitch, I want to set the frequency just down to something low. So let's just pick 100 kilohertz. And I want to change my amplitude to be 1 volts peak to peak. And I got to do that same thing with my with my Trueform generator. So let me change the units to frequency and select 100 kilohertz and 1 volt peak to peak. And I'm actually going to set my output filter to off for this portion of it. So let me go ahead and just turn on both outputs. And I'm going to make this scope window a little bit bigger so you guys can actually see it. So unfortunately with the scope, I don't have as many control capabilities with the scope, so I'm really limited to screen image and trace data capture for BenchVue at this point. BenchVue is at a 1.0 release, so in the future releases, which are coming up pretty soon, we'll actually be updating the features and capabilities of BenchVue. But what I want to do here is I'm going to press auto scale on my front panel. So BenchVue is going to tell me that I need to I pressed the front panel key, so I'm going to resume it. But all I did was press auto scale on the front panel, and here we see our two signals. Trueform is yellow with our 7 points, 1, 2, 3, 4, 5, 6, 7. And as you would guess, the DDS base box has 7 points as well. So nothing too surprising with that. However, if I do change the frequency up to something higher, let's say 2 megahertz, and I change it on both generators, 2 megahertz, and then, oops, forgot to change my filter up to normal. So 2 megahertz there. And on my scope, I'm just going to auto scale that again. And I will get the current screen. So what you can see now is, again, the Trueform generator outputs our 7 points again. And now, all of a sudden, our DDS-based generator is skipping some of those glitch points that we had. Both signals are looking a little bit noisier because we are sampling faster, but we can obviously see that the DDS-based generator is missing some points. So that's one of the major flaws with a DDS-based generator, in that as the higher the frequency goes, the more points that you're going to skip, and it's going to be more obvious. But that's not it. So I wanted to take this one step further, and all I'm going to do now is just change the frequency down to, say, 1 kilohertz on both guys, and just change it right back to 2 megahertz. 2 megahertz. And let's take a look at the scope again. So I want you to pay attention to this green line. So we have our 2 bumps here with the DDS. Let's take a look and see what it looks like now. All of a sudden I have 4 points. So what does that mean? So that means that DDS generators by themselves pick which points that they're going to skip. This is actually very frustrating for engineers, because you cannot predict what type of points will be skipped by that DDS technology. So if you do need to have certain characteristics on your waveform, DDS technology is going to be a little bit limiting for you, in that it's going to skip points and it's going to do it unreliably, unpredictably, let's say that. So I'm going to pop back over to the presentation, and we'll do a little bit of a reflection here. So how did that DDS-based generator differ than the Trueform. Trueform really did output all of our points that we designed in our generator, in our signal. However, the DDS actually started to skip points, and we saw that with those glitches that I had designed in. And then with that second demonstration, was that generator predictable? It wasn't. I mean, anytime that you're going to change that frequency setting, DDS is going to determine its own algorithm to output its points. So that's going to be a little bit frustrating, especially if you need a predictable result. So I don't want to denigrate DDS too much because it is an industry standard. So obviously people love it and they use it right now. However, we have another paradigm. Trueform is going to not have those same types of flaws. So I wanted to mention that even if your waveforms don't show those missing points, so maybe you don't care about this lab as much, those missing points for arbitrary waveforms are going to manifest themselves differently for a DDS generator. So those missing points will actually show themselves as a distortion in your signal, or actually even increase your jitter in your signal as well. So if you are getting too much jitter in your DDS arbitrary waveform, that's going to be because of that missing point. Give me another drink of water. So I did kind of gloss over the use of BenchVue before, but you guys are probably new to BenchVue, so I did want to give you guys a little bit of information about BenchVue too. So BenchVue is a really nice tool to be able to control multiple types of instruments, multiple instruments at the same time on your PC. So if you have struggled with doing that, or you're like a non-programmer and you haven't used your PC to control your instruments before, BenchVue is going to help ease that burden on you. So what's nice about BenchVue is that it's not only free to download, but actually is free to use. So you can actually use BenchVue to control your instruments and capture longer data logs with your instruments on your PC now. So you can go ahead and download your free copy of BenchVue right now at this link right here on the bottom. BenchVue right now actually only supports Agilent products, and we are only supporting 5 families with our 1.0 release. But it's quite a number of products that we are supporting. So we have digital multimeters, 7 different models of DMMs, 16 models of spectrum analyzers. We have an incredible 98 models of scopes, and then power supplies and function generators as well. So if you want to check if your instrument is supported, you can go to this link down here, agilent.com/find/BenchVue instruments, and you can see if your instruments are supported. But let's do another demo with BenchVue, but I want to keep that with the theme of our webinar, which is arbitrary waveforms. So let's actually capture a waveform with an oscilloscope and then output that with the generator, and we're going to use BenchVue to do that again. So I'm just going to pop back over to BenchVue really quick, and we will, let's see, we'll actually do this thing called trace data in the scope. And from the scope, I can actually grab the actual data points from every trace. So what I want to do now is I'm actually going to simulate the DDS-based signal with our 4 points. So I'm actually just going to focus in on this second channel here. And I will actually try to simulate this signal with my Trueform generator. So let's go ahead and do that. First, I'm going to just select this upper right-hand button here, which actually allows me to drag and drop our traces to a generator. And then I will pop over to this 4-tile view. And since I have this button toggled, I can actually just click on my trace and drag that over to my generator. So what I want to change here is I want to change the voltage back to be 1 volt peak to peak, because that's what my original signal was. And then since my requested number of points is 1,000 points and my total time scale is about 1 microsecond, that means that my sampling rate is 1 nanosecond per point, or 1 gigasample per second. So do that, and let's go back to the scope and see if that worked. So do a single run. Oops, I got to change the trigger level real quick on my scope. And we'll do another single run. And oops, and get press start and see how those waveforms look now. All right, so we're a little bit overlapped now, but the DDS generator is at 4 points, which I didn't change the DDS signal at all, but I was able to simulate this DDS signal, my real-world signal, if you will, with my Trueform generator. So all I did was just drag and drop it, change a couple settings to make the signals match, and now we have it. So you can change your frequency settings and amplitude settings as you wish on your real-world signal. So hopefully that's of use to you guys. I mean, I don't know how often you guys do capture signals from your DUT, but that is one of the main features of having an arbitrary generator with a scope. So you can simulate your signals and change parameters very easily with that tool. And hopefully I just showed you that you can do it within less than 10 seconds. Again, I wanted to plug the download for BenchVue, so please go download that right now. Maybe you've already started downloading that while I did my demo, but it's a very useful tool. I do want to talk about another tool here. So we talked about how BenchVue is able to capture and view waveforms on a scope or control your instruments on your PC. That is really used for controlling your instruments, your function generators in particular. However, with if you want to build an arbitrary waveform, which is the theme of our webinar, I want to also talk about this program called Waveform Builder Pro. So Waveform Builder Pro is a program from Agilent that is going to allow you to create an arbitrary waveform. So if you want to do something more complicated with some more math functions or whatever, you can actually use Waveform Builder Pro to create your complex arbitrary waveform signals. One other aspect that I like about Waveform Builder Pro is it allows you to create a sequence, and sequences are only supported with Trueform generators. So we can create a sequence very easily and edit a sequence very easily with Waveform Builder Pro. So let's talk about sequencing. So sequencing is the ability to resort and reuse your current arbitrary waveforms and put them together in new ways to build a brand new waveform. So by allowing you to have the flexibility to mix and match your signals, you can create signals that you need from signals that you've already proven out that are good enough for your design. So that's going to be a very important feature to save you time when you're designing an arbitrary waveform signal. Another feature of sequencing is the ability to smoothly go from one signal to the next by just changing a few settings on your sequence. So we're actually going to create a sequence live now, and I'm going to actually build up Waveform Builder, bring up Waveform Builder Pro. So first thing I'm going to do is I'm just going to create a new sequence here. I'm going to just set that to be a fairly slow sample rate for purposes of my demonstration. And I'm going to press this button called Load Waveforms, and I've already have a couple of arbitrary waveforms that I've built already. So these are just plain old sine waves, but they are an arbitrary waveform versus a normal function. So I can easily drag and drop the signals to be any order that I want, and then I can also change the output parameters or the output repetitions of my waveform. So first I'm going to actually change my first clean sine wave to be a repeat twice. And then I will repeat my noisier sine wave to be repeating twice as well. So this is going to be really useful for you guys if you're doing some stress testing on your designs. If you want to have a clean signal and then all of a sudden you want to see how well your DUT handles a more nasty signal, a dirtier signal. This is going to be really useful to test that all within the same operation. So I'm going to go ahead and send this to my arbitrary waveform, to my Trueform generator. Press send. And now what I'm going to do is bring up BenchVue again. And I'm going to show you another feature of BenchVue, which is pretty cool. I'm going to load up an old instrument state that I had set up specifically for this demo. So I'll do a single, I'll actually just get the current screen because it's already sampling. So here you can see that the signal is exactly as we defined it. So we have two clean sine waves, and then we have two dirty sine waves. So just within a few operations, a few clicks, I was able to generate a brand new signal from my previously designed arbitrary waveforms. Let's go ahead and take this yet another step and actually use some triggering with our signals. So I'm going to pop back over to BenchVue, or sorry, to Waveform Builder Pro, and I'm going to change the parameters just a little bit. So first thing I'm going to do is I'm going to repeat the clean sine wave until trigger, which means that this guy is just going to be a continuous sine wave until I have a trigger event. And then I will want to, let's just change it up to from 2 to 3 samples so that when I do press that trigger button on the generator, I'll get 3 of these noisier sine waves. So I'm just going to send that back over to my generator really quick. And then on my generator, I'm going to pop back over to BenchVue and get the current screen again. So here, what you see is a very continuous, clean sine wave. Nothing too surprising about that. But what I'm going to do next is I'm going to press the single, and then on my function generator, on my Trueform generator, I'm going to press the trigger button, and hopefully I can capture my noisy sine wave. So I'm going to press single and trigger. And I'll just get that current screen from the scope again. And here, you can see that I had my clean sine wave. All of a sudden, I pressed that trigger button, and I was able to transition easily over to my noisy sine wave. So that is going to allow you to smoothly go from one signal to the next by just defining that trigger setting. You can trigger that with either the front panel, a software trigger, or even the external trigger from another instrument. All right, so hopefully these 3 demonstrations are really going to show you the power of arbitrary waveforms with our Trueform generator. So let's go ahead and start our recap. I do want to mention our performance benefits yet again. So our jitter is going to be incredibly less than 1 picosecond. I mean, that's really hard to do. And that's a 200x improvement over the norm, which is a DDS-based generator. We do have that ability to output every point as you want it to be outputted, as you designed it. Unlike DDS at the higher frequencies, it won't, DDS skips points at the higher frequencies. Our signals are going to be cleaner. One aspect I didn't mention earlier is our waveform memory. So a typical DDS-based generator in this class is going to have about 128 kilosamples of waveform memory. That's how many samples or how many points in your arbitrary waveform that you can output before you run out of memory. The Trueform generator has standard 4 megasamples. That's standard with that 33600A series. But if you need even more, you can actually upgrade that to 64 megasamples. So that's incredibly 500x more than a DDS-based generator in the same class. As a real-world example of that, I actually generated I simulated a song file that was about 5.5 minutes long, and this song file turned out to be about 11 megasamples. So when I can easily output that with my Trueform generator. But out of that 5.5 minutes, if I only had 128 K samples of memory, out of 5.5 minutes, I would only be able to output 3 seconds out of that song. So that's sometimes just not enough memory for you, especially if you have those longer waveforms. So that's it's just a big difference there. And then even with sequenced arbitrary waveforms, it's not possible with many DDS-based generators. I think I can say all DDS-based generators, but the sequenced Arbs is an exclusive feature in Trueform generators in this class. So just to summarize the 33600 once again, we do have 4 models, and it is a 1 or 2 channel model, and you can get 80 or 120 megahertz bandwidth versions. So it's going to be a very good product for us. And it is going to cost about $4,000 to $7,000. Some other special functions, special signals that I might not have talked about before is the ability to do variable bandwidth noise. So you can actually define your bandwidth on your noise signal. You can actually do this thing called sum modulation. So sum modulation allows you to add 2 signals together. So you can add channel 1 or channel 2, or you can actually add up to 4 signals together onto a single output. So that's going to be that's going to allow you to create even a very complex signal. And then finally, we actually have this really low voltage range on our products. So this is a 10x improvement over previous DDS generators that are out there. I do want to mention that the 33600A is not the only family with Trueform technology. We do have a 33500B series, and that is a lower bandwidth series of generators that is 20 to 30 megahertz, and the price ranges from $1,600 to about $3,300 US dollars. All right, so my last slide, thanks for bearing with me, but so Trueform is going to have that superior signal fidelity. It's going to not only have the ability to output every point that you design into your signal, but it also has that cleaner distortion that we showed before. So we have the ability to output your signals better, cleaner. So you can also use Trueform generators in more applications than your current function generator just because of that jitter capability. So if you are a digital designer, as I mentioned before, that 1 picosecond of jitter is going to allow you to use your generator in a lot more applications than your older function generator was. So previously you might have had to buy a $20,000 to $30,000 box to get a 1 picosecond of jitter. Now you can do that for a lot less than 10K. We also have that sequencing feature. So I'm always worried about being the most efficient. So mostly because I'm lazy. So I want to be as efficient as possible. So sequencing is going to allow you to be more efficient, not only when you're designing your signals, but also when you're using your signals. You can smoothly go from one signal to another with triggering capabilities or repetition rates. So that's going to allow you to save time when you're configuring your signals. You no longer have to download a new signal to your arbitrary waveform to get a new signal. You can just use sequencing to go to your next signal. And then finally, I wanted to also plug BenchVue once again. It is a free program. You can use it not only on your PC, but there's also tablet or mobile device versions that are out there as well. So if you have an Android or iOS device, you can use BenchVue in conjunction with your PC and your instruments as well. So I believe that's my last slide. All right, so that's about it for me. Looks like my timing's pretty good, so I think I'm ready for some questions. What do you think, Christian?
I think you are. Thanks for that presentation. The first question that we have is, why does the amplitude read 10 volts when I measure the output of my function generator, but I just set 5 volts? I see the voltage doubled in all settings.
Oh, okay. So that's more of a general function generator question, but this is a very common question that we've seen before. So a function generator has to match the load of your device. So say you have a scope. Your scope can either have a 50 ohm load or a 1 mega ohm load, input load. So what you need to do is on your generator, I can actually show this to you guys. you need to match the input load of your scope with the output load setting of your function generator. I think I do that here. Yeah, so I can change my load to be either 50 ohms or maybe high Z. I can actually, so let's just set that to high Z. And so if my scope is in high Z mode as well, high impedance mode, that the amplitude settings are going to match now what your voltages are going to set. What I want to mention though is that this load setting actually doesn't change any hardware settings on your function generator. The generator has a fixed 50 ohm serial resistance output. So all you're doing when you're changing this load setting is allowing the generator to calculate what the viewable, measurable amplitude is at your load. So you're not actually changing the output amplitude. Here is just this setting that you put, so that when you are able, when you output an amplitude, you can predict what the amplitude is going to be at your measured point.
Okay, thank you for that. If you have any questions for David or for his colleague Marlo, please put them into the Q&A or chat windows now. We do have another question. What type of file format are the Arbs for Trueform?
Oh, okay. So the file formats for Trueform are actually in this proprietary format called .arb files or .barb files. A .arb file is a text viewable ASCII-based file format. The BARB is a binary format. So if you want, the BARB file format is faster to download. So if you do have very large waveforms, you're going to want to use a .barb. But if you have a smaller waveform and you want to actually view the file, you can actually use the .arb file. One other thing I wanted to mention is that you can use .csv files as well with your Trueform generator. You can actually import those fairly easily with the Trueform generators via a USB stick or maybe just drag and drop. Import that, and the generator can output and interpret that CSV file into a signal.
Okay, thank you for that. Do we have any further questions from the audience? Going once, going twice. Okay, I'd like to thank you, David and Marlo, for this presentation today. It's very interesting to see these new test and measurement products come out and how the improvements seem to be accruing all the time. Please stay tuned to Element 14 for future webinars from Agilent. And with that, I'd like to thank David and Marlo once more and say goodbye. Goodbye, everyone.
Goodbye.